Okay, so this is infinity. I've talked about this in most of my classes, but, it's just one of those cool things that I kind of geek out at. So we use the term infinity to indicate never ending. I mean, even the symbol itself, the 8 sideways, is never ending. If you try and it has neither a beginning nor an end. So by infinity, we talk about immeasurably everything, right? So there's no largest number, you just add 1, right? So by adding 1, you get to, there's no biggest number. And so that what we use to describe that kind of ultimate term of as big as we can get is infinity. But what if there was a biggest number? So, what are numbers for? Numbers are used for counting. Even an irrational number like 3.14, which goes on forever, pi. We shorten it to 3.14, 3.415. Even an irrational number like that represents something. Pi represents the constant ratio between the circumference and the diameter of a circle. Pi equals the diameter divided by, or the circumference divided by the diameter. And in a circle, that ratio will always be 3.1415, so on and so forth. So we use numbers for counting. So in talking about infinity, we need to talk about what is the most of something there can be. Is there a number so large that after that we can't just add 1 because there'd be nothing more to count? And funny enough, in order to think about a number that large, we need to start really small. So think about small things, okay? We can think about atoms, okay? And for a while, everyone thought that atoms were the smallest thing there was. That if you had gold, you just had a bunch of gold atoms, and that gold bar was made up of gold atoms, and that was the smallest thing there was atoms. And then we learned that there were subatomic particles. And the smallest of these subatomic particles is the electron. So for a while, everyone thought that electrons, those are the smallest things that there are. And then we realized that there are smaller things that make up these subatomic particles. Quarks, bosons, things like that. And ultimately, you keep going, smaller and smaller things. And currently, there is something called string theory. And string theory is this theory that when you break down even things like the Higgs boson, the so-called God particle, the particle that allows atoms to have mass and not blow apart, you end up with, if you broke all those down, you have strings. These little tiny, there are literally billions of these per electron. And they're the building blocks of matter. Okay? So, the string is a belief that there is a smallest indivisible particle. And even if we later find out that strings are made up of something, this whole topic that I'm talking about really goes on the belief that there is, in fact, a smallest indivisible particle. Okay? So, again, what we're talking about is infinity. And in order to really think about infinity as a numerical concept, we have to start super duper small. So let's all, for the sake of argument, agree that there is in fact a smallest indivisible particle. Now, the universe is about 14 billion light years across. Okay? And it's, we think, this big wibbly wobbly ball. It's not really a perfect sphere, but because it expands in different directions at different speeds, but it's currently 14 billion light years across. I forgot to put an R in years. So light years across. And everything is moving away from everything else. Okay? And not only is everything moving away from everything else, but everything is moving away faster from everything else. It's like the Big Bang was at the top of a hill and everything started rolling down the hill. So not only are they getting further and further away from the starting point, but all of these individual solar systems and things like that and galaxies are getting further away from each other at a faster rate. Okay, so not only is our galaxy moving through space, and in general it's moving away from all these other galaxies, but it's moving away faster and faster and faster. So, let's go, we went from really big, 14 billion light years across, and we're going back to really small. And we're going back to the beginning of it all, Big Bang Theory. So the Big Bang Theory says that in the moment before, at the beginning of our universe, all of the matter in the universe was in this ball of pure energy squeezed together without space. Now, one of these other ones that I do is going to be on just how much space there is in the universe and in people in the world. But, I mean, think about that. Think about our sun, our entire solar system, our entire galaxy, every galaxy that you've ever heard of or seen, every single piece of matter squeezed together into something the size of a softball or smaller. And there was so much, and think about when you're in a room with a lot of people, how hot it gets. Think about everything in the universe being in the same spot together. It's going to get really, really hot. And there's this super gravitational pull because it's so dense. But on the other hand, you have all this heat that's pushing everything away. So eventually it explodes. And as it explodes and everything starts to get away from each other, things start to cool. And they start to cool into the basic building blocks of the universe. You know, we think about it in terms of, well, that's when all of the hydrogen atoms formed, which is just one proton, or a proton and a neutron, or a proton and an electron. They all formed just after the Big Bang. But before that happened, when all the matter in the universe was there and it exploded, before it formed hydrogen, before that hydrogen started coalescing and building things like helium and everything else, all those subatomic particles had to form. And ultimately, all the string had to form. So if there was a finite amount of matter in that ball right before the Big Bang happened, then that means when all that energy started to cool and turn from pure energy into matter, that there's a finite amount of string in the universe. So the number of strings in the universe is the biggest possible number, because after that, there is nothing to count. So if you have a small number, or you have the smallest particle in the universe, and we have a universe that has a certain number of those smallest particles, then that number would be the biggest number. And after that, you couldn't say, well, just add 1, because there's nothing that much. There's not that much of anything in existence. And so that would actually be the last number. And that would be, when we're talking about approaching infinity or infinite of this, that would be it.